ultraviolet photon.
We are the electron and the core.
Fluorescence is the emission of light by a substance that has absorbed light of other electromagnetic radiation. The emitted light has a longer wavelength and therefore lower energy than the absorbed radiation. In the particular case of the ultraviolet, its wavelength is not visible to the human eye, and the emitted light is in the visible region of the spectrum. Two electrons spin around the core, while also spinning on their own axis. One of the electrons is trapped and jumps at a higher level. At this point, the electron goes down, but not at its ground state, without losing light energy. Then, the electron falls, releasing a photon of color X with speed x.
This is phosphorescence.
I'm a blue photon.
I'm an ultraviolet photon.
I'm an electron.
I am an electron.
The difference between the phosphorescence and the fluorescence is the time of the effect. When the photon hits the electron in the phosphorescence, it doesn't transmit all its energy, but only a part of it that permits to jump and offer. For this reason, the effect is longer, differently from the fluorescence. So, when it goes to its fundamental state, emits a lower energy than the energy received. For each orbit, maximum 2 electrons can exist, with opposed spin, on the principle of the exclusion of Pauli. When one of these electrons has been excited, jump onto another level, changing its spin. So, to go back to its fundamental state, the electron must have opposed spin to the electron in that level. For this reason, phosphorescence effect lasts more than the fluorescence. Now we can see the scenes. Here we can see two electrons in their fundamental state that turn respectively clockwise and counterclockwise. As we say in the introduction, now we can see a photon that transmits a part of it to the electron that permits the electron to jump in an upper level to change its spin. We can see an electron doing a jump to a lower level without emitting energy. To go back to the fundamental state, it must have opposed spin to the electron present in that level. When the electron arrives at the fundamental state, emits a photon with lower energy than the energy that the photon at first gives to the electron.
This is the photoelectric effect.
We are the blue photons.
We are the red photons.
I'm the ultraviolet photon.
We are the electron.
The photoelectric effect is the observation that many metals emit electrons when light shines upon them. The experiments that led to the discovery of the photoelectric effect have been made by Einstein. Afterwards, he decided to change the wavelength and took a blue light with the same intensity of the red light. Thus, he saw that the blue light instead emitted electrons.
I'm giving my energy.
Then he saw that if he illuminates the plates with red light, it doesn't emit electrons.
Now I give you my energy.
I don't have enough energy.
As a consequence, Einstein thinks that if he increases the intensity, the electrons will be emitted, but it didn't happen.
I will give you our energy.
We don't have enough energy.
Therefore, he decided to increase the intensity of the blue light, and so the light emits more electrons.
We will give you our energy.
Einstein deduced when they change the intensity, the energy who hit the electron is the same. As a consequence, he changed the keep the same intensity and took an UV light. Then he saw the electrons were faster.